Yeah, hello and welcome to our lecture series on climate protection. It's the third lecture today, and today our guest, Heinz Fuchsig, and me will give the lecture about heat pumps. The title is Heartbeats for Heat Pumps in Existing Buildings. So Heinz Fuchsig is a general practitioner, so it will also have some content with health. So we are looking forward to his presentation. But before, I will give you some explanations about heat pumps in existing buildings and about the physics of heat pumps, because last time you raised your hands on the question if you know what a heat pump is and how it works. So I think it's good to have some explanation about that. And furthermore about the F-gas rules, which is related to climate also. So first question, what is a heat pump? And to answer this question, you also have to answer the question how to heat with a heat source at outdoor temperatures. And normally that's not possible. You can't heat with outdoor temperatures. That's the second law of thermodynamics. Heat can only be transferred from high to low temperatures. I think you all know that you only can transport the heat in one direction, from warm to cold. Our ambient is cold, so it's in winter time around whatever 5 degrees centigrade, and we have indoors, we want to have 21 or even more. So there is no way just simply heat with ambient temperatures. That's physically not possible, but we can use some tricks, and I'll show you the tricks how to do it with a heat pump, with the help of a heat pump. So one trick is evaporation. Let's think about a medium, a fluid at low temperature and low pressure. At low pressure, it will evaporate, you know, all the pressure cooker. And if you have high pressure, the evaporation temperature, the boiling temperature is higher. And if you are at low pressure, lower than ambient pressure, then the temperature will also come down. That's the curve for water, and it's different for other mediums. So what we like to do is take heat from the ambient, use it for evaporation of a fluid, of a refrigerant. On the other side, we have condensation, and as you know, for condensation there will be some heat emitted, and this will take place at high temperatures and high pressure. So evaporation and condensation, and in between you need some machine, which is a kind of compressor. It's a in this case, it's just like a bicycle air pump. You all know if you compress air with a bicycle air pump, it feels warm. Yeah? The higher the pressure is, the warmer the air gets inside the pump. And the other way around, if you expand the air, it will reduce the temperature. It's cooled. So we take the vapor from our evaporation, we compress it, so we end up with higher temperature and high pressure, and then condensation will take place. And in order to come back to this low temperature, low pressure, we have to expand the refrigerant. So as it looks in a technical circle, we have the evaporator, we have the compressor. Okay, it's not a bicycle pump, but it's a compressor machine, as you know from refrigerators. And then we have a condenser. And just to expand it again, we need a throttle valve. And that's all about a heat pump. And what we want to have is a very high efficient heat pump. And the efficiency is rated in the so-called COP. It's given as a ratio of heat supply to electrical energy used. Our compressor needs electricity to run, and what we use is the heat from the heat pump. So the ratio of supply heat supplied to electrical energy consumption is the COP. So let's look how big it is. So it's like an energy balance. This is our heat pump. Here is the ambient heat. We have the ambient heat plus the electricity from the compressor, and that's the heat which goes out of the system into our house, into our building. And the COP, the coefficient of performance in terms of heating, is the heat, what we use, divided by the electricity we need for the compressor. And the higher this value is, the better. And you all have such a machine at home. I'm sure you have a refrigerator in your kitchen, and what you use in this case is not the heat, but the heat you subtract from the refrigerator, from the inside of this box. You take out the heat, and on the rear side of the refrigerator, you find this black metallic plate, which gets warmer, and that releases the heat to your kitchen. In summertime, that's not good because it's warmer and warmer, but the refrigerator has to get rid of the heat, and it does it on the rear side of your refrigerator. Inside, your bottles or whatever is cooled down. Yeah, so why not also use heat pumps for cooling in our buildings, not only for the refrigerator, but also in our buildings? And yes, that's possible. Heinz Fuchsig will show us his own building today. What do we have to do in order to have a reversible heat pump? Just reverse the cycle. So as you see the arrows here, the cycling is counterclockwise. So the compressor now rises the pressure to the left-hand side. The excess heat is given to the ambient, and we subtract heat from our building. That's the way to cool with a heat pump. Not all heat pumps can do so because you have to switch the direction of the compressor, or with valves you have to reverse it. But some of these, or I think so, even most of the heat pumps can do so. But be aware of the efficiency. The calculation is just the same as before. We have the energy balance. Cooling energy plus electricity is the ambient heat, which is given from the heat pump to the ambient. So we again can calculate the efficiency. In this case, the cooling is that what we need, the heat subtracted from the building, divided again by the electricity. Unfortunately, this is lower than the COP of heating. It's COP of heating -1. So just out of these simple calculations, you can end up with this term COP -1. Unfortunately, not so efficient for cooling as for heating, but still good efficiency. And in summertime, we have sunshine also on our photovoltaics. So we have electricity maybe from photovoltaics to produce the electricity for the compressor. And now about the refrigerant. I always talk about this special fluid which evaporates. So it's a liquid that evaporates at low temperature and low pressure to absorb the ambient heat. That's what the refrigerant is made for. But it has to have different properties. First of all, as already mentioned, it has to evaporate at low temperatures, but it shouldn't be harmful to us, but also not to the ozone layer. It shouldn't be toxic. It should be not explosive if possible. And in addition, they should have the lowest possible GWP. So what is GWP? We learned in the last lecture from Armin Hansel, the global warming potential. You know, global warming potential from CO2, and other gases have higher GWP. So you multiply it with a factor GWP. CO2 is 1, and other gases have higher values. So the F gases, fluorinated greenhouse gases, such as hydrofluorocarbons, HFCs, are not considered ozone-depleting substances. They were developed as replacement for ozone-depleting substances like chlorfluorocarbons, CFS, which are known to harm the ozone layer. But these F gases, well, they don't directly deplete the ozone, but they are potent greenhouse gases with high GWP, with high global warming potential. So the Montreal Protocol, which successfully phased out many of these ODS, now also addresses the reduction of these HFS to mitigate climate change impact. So the European community regulates these and says we have to reduce the emission of these gases. Just some numbers, what the GWP of CO2 is, we already learned, it's 1. So the warming potential of emitting CO2 is rated to 1, and other gases like fluorinated refrigerants such as R410A has a value of 2088. So 2088 times the harmfulness of CO2 by this type of gases. So you see, it's important to be careful with this type of gases. Don't release them to the atmosphere to avoid this global warming. Other example is R134A, other refrigerant. This has a GWP of 1,430. So you see really big values. And the goal is to bring them down to values lower than 150. If you are interested in the time schedule, you'll find the link where you can find the schedule for reduction of these GWPs of the refrigerants in the according to the legislation. The legislation is the F-gas regulation, which entered in force on March 1st, 2024. And in the coming years, the synthetic refrigerants that have dominated up to now will gradually be replaced by natural refrigerants such as propane, ammonia, or CO2. Unfortunately, most of these are flammable, so be careful with that. I will show you how to deal with that in heat pumps. You can, charge the limit. So the maximum is, if you want to use it indoors for propane, reduce the amount of liquid to 150 milliliters. That's allowed. The explosion danger is not a problem if you have lower values, or you have well ventilated places, or you place the equipment outside, so in the ambient, then you don't have the problem. So in future we will mostly stick to these 3 or 4 types of refrigerants. Most important will be propane, R290, which is a GWP of 3. Okay, it's not 1 like CO2, but 3, also a rather low value. Or even ammonia or water can be used as refrigerant. So if you use propane, mostly it's done with monoblock devices. I'll show you like they look like. They are completely located outside. So the flammability of propane is not a problem. Yeah, what kind of system designs exist? The so-called monoblock is a unit made out of the heat exchanger and the compressor in one unit. So that's why it's called mono one, so one block all in one. And the heat comes to the inside via a water circuit. Everybody can install it, so it's easy installation. No refrigerant certificate is required for installation. And the refrigeration circuit is completely created and filled in the factory. Or you can place it, if it's not propane, you can place it in your cellar or in the basement or in the ground floor and use such kind of air intakes and outlets on the facade. That's also a monoblock machine that also works. Or you split it up. So in two parts, one part is outside and the other part is inside. So the heat exchanger is outside, the compressor is inside. But then you have the medium, the refrigerant, also indoors. So you are limited to this 150 for avoiding this inflammability or explosion. Yeah, this can emit heat by air or radiator. Yeah, and now to the efficiency. We already talked about the COP, about the coefficient of performance. So that's the rating of the efficiency. And we take, for example, 1 kilowatt hour energy of electricity for the compressor. We add up 4 kilowatt hours for ambient, the ambient heat source, and we end up with a COP of 5. That's a really high and good value, just for an example. So the efficiency, or the COP, is in this case is 5. It always depends on the conditions of the boundary conditions, on the heat source temperature and on the heat sink temperature. This diagram shows you on the x-axis the heat sink temperature rising, and you see the COP decreases with rising sink temperature. And if you decrease the source temperature, you also decrease the COP. So what you are looking for is high ambient temperatures or low sink temperatures, and we can have a look how to do this in practice. How could you do this at home in your house? When you buy a heat pump, you have a label on the product, similar like for refrigerants or other household appliances. And they have the rating of the so-called seasonal COP. That's the COP over the heating period. So there is a rating in these classes. You all know these colors and letters. So from A to D. But unfortunately, they have this label for all types of or all heat generators. And the best gas boilers are rated in A, so that's the middle one, the yellow one. And if you have better ones, it's A+, A++, and A++. That was introduced because the heat pumps were so efficient. So, but the A+++ is not efficient enough. So the best heat pumps today are are A6+. So you need 6 pluses for the very best units. If you buy a heat pump, you should stick to, at least to A+++. So 3 plus is the minimum, and more is not on the label. So you have to look on the precise values what the machine really can perform. And yeah, the best would have 6 plus. In total, so really, really efficient ones. And you see for what it is used, for heating or for domestic hot water, you see also the sound rating, the sound emission, the noise emission, and the power. So what can you do to rise the efficiency? On one hand, you can increase the temperature of your source by geothermal drilling, by ground collectors, by groundwater or river water, exhaust air, waste heat, whatever, instead of outside air. Or you can reduce your temperature on the heating side. So Heinz Fuchsig will show how he did it at home in his house with the radiators. It was a good trick. And so you can come better with the efficiency. So 10 degrees are, as a rule of thumb, around 30 up to 40% lower electricity costs for your heat pump. So this way might be somehow cheaper than to invest a lot in geothermal drilling or whatever. If you have a private house or a small building, maybe the outdoor air is much cheaper. If you want to inform yourself about the units, you find in Austria the GET database for all types of heat pumps, air water, brine water, water, and so on. And you find on the Passive House component database, on an international database, all the heat pumps worldwide. Yeah, what kind of heat sources are available? In the ground, there are a lot of possibilities. The deeper you go, the better, the warmer the ground is, but it's more expensive. Mostly, the deeper you dig. So geothermal baskets or ring trench collectors or ground collectors, or even deeper, that's the ground probes. You drill holes and guide some fluid in the ground. Or you just use the ambient air or groundwater wells. That's what you used in your building. You can also use extract air from your ventilation system. Or maybe you have good luck that in your district, a cold district heating network is available. Then you can directly connect your heat pump to this kind of heat source. And now to the other side, what's inside your building? How do you heat your building? Normally, I think most of you have some radiators at home. These are in the temperature range of around 50, 55 degrees centigrade. As you know, heat pumps want to have low temperatures. That's the best way for the high efficiencies. So how to come down with this temperature via fans, you will explain it more in detail, or with bigger surfaces like floor heating or wall or ceiling or whatever. So then you also reduce your supply temperature and can rise your efficiency. Last but not least, some myths and facts about heat pumps. The claim heat pumps only work in new buildings is false. We will hear from Heinz Fuchsig today. Yes, it's really also possible in existing buildings. The claim heat pumps only make sense with underfloor heating is false. There are other techniques possible. And the claim geothermal heat pump is always better than air heat pumps is also false. Just think about summertime. If you want to produce domestic hot water, the ambient air is much better than ground source. Well, in wintertime it might be other way around, but in summertime it could be better to do it with air heat. And the claim air heat pump is too loud for residential area is also wrong. There are very quiet air heat pumps that do not cause any disturbance in the residential areas. And one good message for you is if you reduce the power of your heat pump, you also reduce the sound of your heat pump. So it's always good to reduce the heat load of your building, and that's you do by refurbishing, by energy efficient refurbishing. Other myth is the claim heat pumps only work in houses that have been completely renovated to improve the energy efficiency. Well, it's false. It also works in not renovated, but it's good to do so, as already mentioned. So the heat pumps can be also work in uninsulated houses, but insulated houses always make sense regardless of heating systems on economically, ecologically, and in terms of comfort. The claim we will never have enough electricity for everyone to be able to heat with heat pumps. I always say the future will be electric, so we will drive electric cars, we will heat our buildings electrically. Is there enough energy in form of electricity available in future in a decarbonized way? Well, we need wind power for that, and we need really come down with our consumption. So we need to have high efficient refurbished buildings. Especially in wintertime, we have a lack of solar from photovoltaics. So it's really important that your buildings will have reduced heat consumption in the core winter time. Yeah, so far about heat pumps and what it's all about. If you have any questions to this short wrap up of what is a heat pump, I hope you know now what is a heat pump, but if you have still any questions, just raise your hand. We will answer all your questions. Please use the mic for the online participants. And yeah, I'll have a look on the chat if there are some messages in the chat. Doesn't look like. So yeah, then I would like to introduce Heinz Fuchsig. Heinz Fuchsig is general practitioner and works in the field of occupational and environmental medicine as environmental officer in the Austrian Medical Association and Medical Association for Tyrol. He worked for AUVA, and nowadays as consultant, for example, about healthy buildings and occupational health management. He already gave a lecture in summer semester 2022 about planetary and human health. So if you are interested in this, it was a really nice presentation. You will find it recorded in YouTube. You have the link in my presentation. So if you want to hear this lecture from 2022, you are highly welcome. Also, today his lecture is somehow connected to health, I think so, but also to heat pumps. As the title of the lecture already suggests, heartbeats for heat pumps in existing buildings. So had something to do with health, I think. Yeah, welcome, Heinz Fuchsig. Thank you for coming.
Thanks, Thanks, Rainer, and have a nice afternoon, all participants. I have to excuse for my English. I had no chance to practice since 2022, so there's no improvements. Okay, and I will introduce you into my house, which was built 1908. It's a Gründerzeithaus in Vienna alone. There are 15,000 such buildings, so it has a high potential for making the Energiewende. Yeah, and I will show you some social innovations too, because that's the more emotional part to tell the story, and it works more. I have a question: if Tyrol 2050 is right, because it's too late. We have to decarbonize till 2040. We all know that. And to have energy autonomy is perhaps not the right aim, because we have no food autonomy in Tyrol. Or we import 95% of our cereals, and we have something to export if tourism doesn't work anymore for any big crisis. The big crisis we all realize is that the heat is going on. Here you can see that the experts say the biggest thing to do in existing buildings is to reduce heating in summer. We have to save energy, we have to switch to renewables, and we have to reduce the sealant of our floors. We have a too heavy demand for resources. You know, circular economy is also a theme. Loneliness is not only a medical problem, and in my case, I have 6 migrant families in my house, 5 from Germany, 1 from South Tyrol. So they have no grandparents for the children. And we are in Tyrol, very healthy. In Burgenland, only 56 healthy years you can expect, and in Tyrol, 71 men and women, because we have more exercise than in the east of Austria. That's the main reason, I suppose. Yeah, here you can see 2 recent publications from the Wissenschaftlichen Beirat of the German Bundesregierung, the government, and one was the transformative power of cities, 2016, and planetary health, what we have to talk about 2023. Old buildings in Innsbruck built before 1990 have usually 200 kilowatt hours heat demand per square meter. And we have recompaction. So I don't know if somebody of Absam is here, but it's a joke, Absam. And we have more and more warm water in the ground. In Vienna, I heard it's in mean of 17 degrees. In Innsbruck, it's between 12 and 19 degrees. 19 degrees, it's east of Innsbruck, where Detz, the shopping center, cools all their lightning and all energy into the ground. We have nearly 700,000 e-boilers for making hot water. To my mind, very inefficient technique. And we have in Innsbruck not really enough of renewable sources for district heating. In Kematen, there will be built biomass burning 20 megawatts of heating. We need about 100 megawatts, I suppose. Why not bigger? If you build 21 megawatt, you have to do environmental proof, Umweltverträglichkeitsprüfung. So it would be a much higher effort to get the rights to build it. Okay, here you see our demand shrinks, not only because we do more insulation. I think the main cause for a shrinking heating demand is warmer winters. That's my house. You can see the facade to the street. This is insulated with 8 centimeters of cork. It was done 1996, and it's altogether about 1,100 square meters gross floor area. It's west and east. This side is the east side. There is no solar gains in winter, but very high solar gains in summer. So I have a really cooling problem. Yeah, we had panel heating or floor heating or wall heating only in the 2 attic tops. And till 1990, there were coal and oil heatings, and in the 90s, everybody installed gas heating. And 2005, we installed 1 pellet heating, and altogether, they needed about 70 megawatt hours per year, plus 25 megawatt hours per year electricity because of the boilers, and the little flat here, this one was direct heated. And after installing the heat pumps, we now have 20 megawatt hours power electricity for all 3 demands, for heating, for warm water, and for cooling all together. We have less electricity demand than before, but 90% in winter. Here there were the official scheme, and they said don't do it. Yeah, because there's a too big heat demand, and we have radiators and no floor heatings. And we tried it without being sure that it will work. I had one measurement, data logging in 2 flats, and I saw, okay, it could work. What did we do? Accompanying measures. We serviced the windows. We told our lessors that it could be impossible to reach more than 21 degrees centigrade. But we had a dement couple on the floor living there, and we did low temp. We installed, instead of the direct heating with electricity, low temperature heaters, and now we reach 25 degrees in this flat. One lessor told me he found something in the internet. It is a heat amplifier. This is with magnetic points, and you can put it under your radiators, and it brings out 80% more heat than a usual radiator. And here you can see a lot of installation is not insulated. We insulated with wool by my own hand, because it would be very expensive to do it professional. Yeah, we have 4 conductors, warm water up, cold water down. In the flats there is a Übergabestation, a heat exchanger, kind of heat exchanger, so the fresh water comes with 45 degrees. There's no problem with Legionellen. And we have the second system for heating, and in summer it's switches to cooling. So till 15 degrees outside temperature, it's warm water coming up, above 20 degrees cold water coming up. Yeah, the groundwater has 13 degrees, so that's a very good source for the heat pumps. And we have, for reason of comfort and not to have too much work with the system, a machine who does the automatic refill of the system and the degasification. So the 10 mans, the lessors, they don't have work with, no work at all. So that's what at the end the outcome is, or is it COP? COP is 3.5. You can see the heat pumps here. In the meantime, the small one has 5 kilowatts and brings out 20 kilowatts, and this is 10 and brings out 40 kilowatts. This is for heating, this is for warm water, but they can help each other, and this is the sheep wool on all the not insulated parts of the thing. And the sound of the machines, they are decoupled with rubber, and these are elastic, so that the sound is not through the system. You can't hear it in the flats. And here you can see the wind. That's Germany. In winter it's wind and not very much solar, and in summer it's more solar. It's I think it's 2 years old. In the meantime, it's much higher. The solar and the wind is a bit higher. So in future, I will from June on said the electricity supplier, they will bring a flex tariff. So if the renewables are high in the power grid, I can use it in these hours. Okay, yeah, smart grid. I hope we will have wind power in Tyrol too. For example, on the Timmelsjoch, I don't know if somebody knows the Timmelsjoch, it's 2,450 meters high, so it's higher than it's in our official Tyrol potential, so it's no potential, but you have a street there and 7,000 motorbikes per day. So you won't hear any wind turbine there, and it could be supply the whole demand of Innsbruck. Only one wind park there. Okay, that's the last 3 months. Just probably some know the electricity map where the electricity comes from. That's water from the Danube or the Inn, the Drau, and so on. That's pump water from Tiwak probably, or Zillertal, that's Verbund. That's solar in winter, it's very small, and that's wind. So in the last 3 months, we had more wind power in our grids than the usual water power. For our lessors, they have 90 square meters flats, and if the price of electricity is 30 cents per kilowatt hour, probably it's a bit cheaper at the moment. You pay 38 for heating, 11 for warm water, and 12 for service and the metering. Yeah, for the metering. Thanks. So it's 61 per month. The investment was 300,000. We got the sponsorship, or how is it called, subsidies of 100,000, and the whole money stays in Tyrol because it's a Tyrol machine and workers. And you have a write down for the tax, and the cost for the lessors will be reduced through smart grid at about 45 euros per month. And the remaining cost for me were about 10,000 euros per flat. So it's for me, it's no business, but I think it's an investment for 3, 4, 6, 60 years. The future is now. Since 3 years we are cooling with the systems. Here you on the left hand, you can see a radiator which has, was heißt Vorlauf, Rücklauf? Supply and return on the bottom. So the cold water runs in and runs out. And the whole radiator has room temperature. Here you see a low temperature radiator with inbuilt ventilators, 1, 2, 3, 4. And that brings the cold water to the whole surface. And that's here in the attic. We have wall heating. Here you can see it's cooling the whole attic. And last summer we had some problems with regulation. We had too cold in summer. Yeah, but what's the future? We have one EV and one hybrid now shared. We have 36 people living in that building in 12 flats. And we have 8 mobiles, and we have in future about 7. I will install photovoltaics when the thermal collectors break down, so then I have 20,000 kilowatt hours probably earnings, and smart grid is just in front of the door. I could supply the 2 neighbor buildings with heat because I have much more. I could generate much more than I need. They are better insulated buildings than mine. And if one flat comes back and is empty, I will take one room for co-working and storage capacity for our families. We had EcoGood certification in 2020. You know, probably EcoGood Gemeinwohlökonomie. And so you can say what is with the suppliers and what's your footprint for the community and so on. We use not only kitchen and sporting goods together, we also use goods which we gave to the Leihladen. So you can go there and get a Kercher, for example, or gardening goods, but you need once a year. That's our common deep freeze. So you can rent for €2 a month 60 liters of space in the cellar if you have not enough in your rooms. We do some common shoppings, fruits and disposal, because we have a few dustbins and they are overcrowded, so we have to do it carefully. And yeah, if you want to look at the building, there was a video done from ORF 2020. And you can look at it with this link. We have WhatsApp groups. For example, here, I read it in German. What's my favorite? Hallo, geht morgen früh jemand zufällig zum Moschen, das ist der Bäcker, und könnte uns ein Klausis Bauerbrot mitbringen oder alternativ 3 Scheiben Brot für die Kinder zum Frühstück. Liebe Grüße, Olli mit Hugo und Susi um 23:13 Uhr und Magnus schreibt um 6:29 Uhr, hab's euch vor die Tür gelegt. Also it works very well. If you need a slide or you have problems with your computer, some other things, you can get help inside the house. That are the people who are not allowed to go into the house, even not with a pipeline. So, ich muss draußen bleiben. You can see the hundreds of billions of dollars he earns from him. They are aimed to buy military goods. Not really a peace project. Yeah, we won't buy such cars. I saw it on a Porsche shortly afterwards, so I think this car crashed. And that's our bringing the people together is a party in summer. It's since more than 20 years. And so you get to know your neighbors, and so it's growing each year, every year. And now we have a Christmas singing in December too. So most are coming, and the children, they love it. They ask, when will it happen, and so on. Yeah, you can take the child out of the house, but you can't take the house out of the child. You probably know the words. Children need a village to be educated, and I think we are a kind of a little village. We have no rebound effects. In former times we had lessors who paid nearly nothing. They had big cars or sailing with cross ships through the world, but now we have very ecological orientated people. Or we didn't look after, but I think we educate each other. We have 2 pets for all, and we had no conflicts in the last 15 years, so it was really fine to live in. And the people, about 60 people I've seen leaving the house because they have their jobs in other countries or anyway, and they take something with them. We try to do it beautiful. So this is one former balcony, which was insulated with Fichte and Lärche, no, without, also unbehandelt. And in between there are 10 centimeters insulation and 3 windows. And here is the kitchen. Everybody takes it as a dining room. And if you have guests, they sleep here. So it's 8 square meters. It's not really big, but it's the living room of everybody. Here we have the greening of the roof, and here is our fitness. You can row here. And we have big aims to reach with climate change. You can imagine you want to go here. If you get up early, you see the blue hour. If you go with friends, if you know the way is here, going here, here, and then here. So it's no difficulty at all. It's a long way, but after 3 hours, you are on the peak. It could be a warning signal. It's a wind that brings the snow in the air, but it's the weather forecast says there's no change of weather. It's only wind. And in that time, I hope some people go the same way, and thank for your attention. And I'm happy with questions.
Thank you very much, Heinz Fuchsig, for this presentation. Really good. I think you heat your building with the warmth of the people, so you don't need any heat pump. That's enough.
Yeah, we always tell if the heat is on in summer, how to reduce aggression. Don't reduce social warmth.
Yeah. Yeah, if there are any questions, just raise your hand and I'll come over with the microphone that also the other people from online participants can hear you.
In the meantime, you can get heat pumps who are 50% more efficient than mine. So I could reduce with perfect things all together, probably the costs for warm water heating and cooling to 35 or even 30 euros per month. I have no pressure to insulate the facade of the side to the west, to the garden, only if it's coming too hot. So it's a heat insulation.
Yeah, your last slides were some issues about economy of the common good. So if people are interested in this, there was also a lecture on this in, I think, 2 semesters ago. So just have a look on the YouTube video. So, but what I think was also interesting was the common refrigerator. You've seen there was a deep freezer for other participants. And this is a really good idea, and you already know why. As I mentioned, the deeper the temperature in the refrigerator, the worse is the efficiency. So if you have a normal refrigerator with a deep freezer in the upper part, it's not so efficient like a standard refrigerator without. So if you have a common one in the cellar or in a common room, everybody can use it, and it takes less electricity than if everybody has a deep freezer in his own flat. So.
One comment to the room here. I have a measurement of CO2. It's about the same level as outside. We have 22 degrees centigrade, and we had, before I came with my sweating hand to there, we had 9% of humidity. Yeah, 9%. So it's much over ventilated room here. Yeah, you could save, I think, tenfold of air and energy if you do it with sensor, with a if the only the real demand. Yeah.
And the reason is that don't blame you. I don't blame all these who are not in the room. This room is for 600 participants. I think the weather is too nice today, so they are outside. That's also good. So tell your friends and all enthusiasts to come to the lecture hall. It's open to public. It's open to everybody. So just make some advertisement for that.
And that's really a problem because the low humidity dries our surfaces, and that's the first part of our immune system. Yeah? You have less viruses in the room, but more infections. Yeah? Yeah, and also if you exhale aerosols, there are very small balls of water with nearly nothing in it. The virus is less than 1,000th of 1%. And if it's dry air, the humidity, the water evaporates, and this aerosol is standing in the room. It has no weight to be on surfaces. So it's not healthy to over-ventilate rooms.
So it's a good advice to measure the humidity in the air humidity with a hygrometer at home, so you can see if you have problems with it or not. That's an issue of health, yeah. One question to the smart grid. I think not all of you are familiar with the smart grid in Innsbruck. Have you heard about it? Or maybe you have read about this. There are some posters on the walls. Here will be built some small grid. You know about? Ever heard about that? That's a grid with low temperature, and then you can connect your heat pump to this. So that not everybody has to drill a hole for a probe, for a ground probe. That's rather expensive, and maybe you don't have space in your garden, or then you can connect to the grid. It's not high temperature like a normal district heating, but it's district heating at low temperature values. Yeah.
But it's only Bozenerplatz and so on.
Yes.
Yeah. And when I mentioned smart grid, I meant smart grid from electricity with the smart meters. Okay. So you can have the signal now. There is low CO2 on each kilowatt hour, on the power is cheap. Then the two heat pumps fill 3,000 liters of boilers, and in 4 hours I can supply the demand for the whole day. So that's we are with a netzdienlich. So it's a service for the net or for the IKB or TIVAC.
Thank you very much for your talk. Very interesting. 2 questions. What is the source for your heat pump? I didn't get it.
What is
the source for your heat pump?
The source is groundwater with 13 degrees centigrade about.
And are you planning to go into this grid that Rainer just mentioned also, or to connect your building to this grid in the future?
No, that would be of no use for me. I could supply warmth for the neighbors' buildings, because they are very good insulated, so they have a very low demand. And yeah, if I do my whole roof with the best PV which is on the market, I could do more electricity than is used for heating, but in the wrong time, not in winter. But it would be used from the house anyway, so approximately the same amount for household energy is used for computers, lighting, washing, cooking, and so on.
Okay, and one last question. You mentioned hybrid PV, if I read that correctly?
Hybrid PV is warm water and electricity collected from the same collector. So if you have a lack of space on your roof, you have to do it all on the same space if possible.
Thank you very much.
Yeah, pleasure.
Yeah, and you mentioned these radiators with the inbuilt fans. So if you want to set up a new radiator, you can just buy it with a fan included, or if you have an old radiator, you can put it underneath to enhance the convection. So a standard radiator just is ventilated by convection because the warm air has a lower density. So there's convection, natural convection, but it's not so strong. And with these fans, it's activated, so the convection is higher and the heat is higher, so the temperature drops, and that's good for the heat pump, for the efficiency.
This summer I want to try it for cooling. If the Heizkörperverstärker with the ventilator brings in a usual radiator more of cooling. And if some students want to do their work, my house is open. I think there are some points where we could do it better.
For bachelor or master thesis, you're welcome. Okay. Looking for some questions in the chat. No, it doesn't look like this. So any questions in the audience? Doesn't look like this. So I would say thank you very much for coming. Thank you for all of you. And yeah, see you next week, I think, is the next lecture. Thank you very much.
Thanks a lot.
Thank you.
Bye.